how we clean up the mess on the planet we've done that we brought us to this point. Is Benjamin online? Do you see Benjamin in the background?
Yes, I'm online.
Hello?
Yes, sir. Yes, Mr.
Benjamin, you have to increase your voice. Your sound is too low.
Okay. I'm online, sir.
Yes, but you're too faint. Increase your volume.
Okay, I'm increasing again.
It sounds you're speaking to us from Mars. Are you there?
Okay. Can you hear me, sir?
Yes, a bit better.
Okay. So,
Okay,
I'm online.
you're online. Okay, what do you have on the development of the cleanup from Africa?
I didn't hear you. Okay. We have what do you call it? The result, brim water treatment result released yesterday. So I have a presentation to make and also to show you some few things that I
Do you
came
want to
across.
share the screen?
Okay, yeah,
We
I'm going to
already know
share.
we had the data regarding the water cleanup from the sediments and materials. Have you managed to do a microbiology tests, or does he have,
The
or do we have
micro
any data?
the microbiology tests, I have taken it to the lab and they want to culture it for 3 days, and today is the third day. So tomorrow actually is a holiday here. So maybe when the holiday resumes, that is when I will get the results of the treated uh, microbiology test. I will
Have
get
you
the
got
result.
any results at all from them yet?
Not yet, not
Mhm.
yet. And then I've sent some samples to the reactor session for a nuclear test to be done on the sample from Ofin and then Pra. So they are also doing that. So when we come back from holidays, I will get all the results in this area concerning the microbiology and the nuclear test. But for now, like I shared with you the other day, I use copper nitrate and converted it into COU, copper oxide gas, and then use it to treat the Brim River, uh, polluted river. And the analysis is what I have to share with you today. In fact, Nash should have joined us here, but there are a lot of work for him because of the coming of the IEA boss here, Mr. UKR Amano here. So a lot of work was piled on him, and they have to do other things. So he told me he will be here, but he has not honored his word. Uh, by being here, maybe he's taking care of some of the jobs, that were piled up. So, but I have done a presentation, and I'm ready to share with all. Okay, so I'm going ahead. Share screen, and we go to PowerPoint. So, am I online? Hello? Hello?
You are
Yes, we can
coming up.
hear you.
We're
Okay.
waiting for you to come up.
I have shared my screen.
Yes, but we don't see anything. It's just blank.
It's blank.
Might take a few seconds.
Okay. So, if you can see now, or
No,
okay, stop share and then share again. So, please, can you see?
Yeah, it's coming up. It's up here.
Okay, so that is a water treatment result from Brim. The results.
Yes.
Um, uh, Brim is one of the most polluted water bodies in Ghana as at now because I was thinking about wrapping my mind around it, why people go to that particular area to pollute the river. And I came across a document from this guy by Komla Jigboji Jima, Geology and Geochemical Patterns of Brimarian Gold Deposit, Ghana, West Africa. So I found out that uh, because of the gold in this particular river, you can get gold and diamonds at the same time, you know, and what we call alluvial diamonds. So you get a pure diamond in it pure state. So people actually like going to this area to, do the mining there. And I remember when I went there the first time, I took some pictures and then shared with Mr. Kesh, and Mr. Kesh replied back. He said, "God save that country, because the water is really really polluted." And I have a gallon sitting in the office of the Tanana. When you open it, you can even smell. After closing it for some time, you see that the smell is very bad, so it's really 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 contaminated or polluted. And um Blame River is a major, what do you call it, tributary to this river Pra. As you can see on the board, on the screen, we have River Fin, and then River Enum, and then River Brim. And then these are, what do you call it, tributaries. When I say tributaries, that means they are contributing to the Pra River before it enters into the Atlantic Ocean. And so people actually like mining, and in all this area, there are rocks. We call this rock the Brimarian rocks, and in these rocks are huge deposits of gold. And that is why Ghana even was some time ago called Gold Coast, because I learned from history that the white men that came here the first time, when they walk on the coast of Elmina, which means in Portuguese the mine. Elmina, they were working on gold. They were picking gold from the sea sand, and it recently also happened again that the same effect was witnessed again in the same place in Elmina, that fishermen who went to shore suddenly started picking gold on the shore, on the seashore. So I mean, we are blessed with a lot of gold, and that is where Pra actually enters into the sea. Elmina, the town of Elmina, if you can see it down. Okay, so let's go on. And last 3 days, I think I was listening to the radio, because it's a huge, what do you call it, discussion here in the media, as I have already hinted. And one of the guys, Mr. Benjamin Amponsa of the Water Research Institute, made a reference to this fact that they are finding a huge problem of treating the water. And actually, to hint Mr. Keshi about what is happening, the Water Research Institute also are working in tandem with us. That means what I'm doing, they are also doing the same thing. And what I submitted, the samples that I submitted to the laboratory at GAIEC, they also had the same sample from me using the copper oxide, and they have requested to get another sample or copper oxide gans from me, so that they can treat the water again. Okay, so that is what is happening in the interim. Okay, what is and why is WQI important? Okay, WQI is actually the abbreviation for water quality index. Okay, water quality index is reference for physical and physical, chemical, and biological idiosyncratic of water body. Okay, this distinctive aspect of water determines how far water can be used and the species and the ecosystem process can support it. Okay, so that is the water quality index. So we are looking at the physical, chemical, and the biological idiosyncrasies. Okay. For now, all that you have seen is mostly the physical and the chemical. The biological is what we are looking at from the lab of the GAIEC microbiology lab, and I was there the other time. I started the process with this man Daniel in charge of the lab, and we'll soon give you the data as I have said earlier. So, uh, water quality index has a particular range. We have for good water quality, you get from 90 between 90 and 100, and excellent quality from 70 to 90. 50 to 70 is good. Medium to 50, medium is from 25 to 50, and bad is from 0 to 25. And the other day when Mr. Benjamin Amponsa was speaking, being interviewed on one of the radio stations, he made a claim that the water is so bad that it's classified in this range, that is 0 to 25, very bad. So that is what is happening here. And to wait, um, we have a huge problem here, and they are looking for various ways of solving this problem. And when I quote some of the amount in dollars, you shake your head. But like I said, most of the things are also not within the uh, power of the people to do it, because there are political connotations with what is happening also, because most of these guys doing the illegal mining, it's the politicians and the people who are in power who supply these young people with some of these devices and to pollute the river, and they also back them, so you cannot touch them. Okay, these are some of the determinant factors. So if you have look at some of the results, I'm trying to uh, discuss this because most of you see some of these things and you don't actually understand what it means, and I'm trying to get it clear to you. So these are the factors that determines the quality of a water. That is, in some books you see it as D-ul, and D-ul is dissolved oxygen. It is the amount of oxygen that is present in the water, you know. And fecal or coliform, that is what the biological people are going to do. Bacteria are the most common biological contaminants of natural water. So these are bacteria, fecal coliform are bacteria that are most common in microbiological contaminant of natural water. And pH is the numeric scale. As for pH, I know many people have heard of it. Is the numeric scale used to specify that water is acidic or alkaline. So you from seven going, the water is alkaline, and below that is acidic. So, for instance, when you take a substance like vinegar is 3.0, that is acidic, and when you take a good quality water that is tasty, that is alkaline, and it ranges from seven upwards up to 10. Okay, so that is the alkalinity range. Biochemical oxygen demand is a demand for measure of the quality of water used by microorganisms. So you also find that in some cases you see something like BOD, that is biochemical oxygen demand, and it's the measure of quantity of oxygen used by microorganisms, either aerobic bacteria in the oxidation of the organic matter, so in the water. Temperature change. Temperature change can have a lot of influence on the quality of life in the water, like fishes and other aquatic bodies. So it is a change of temperature in the water, and it is either a natural change or a human driven event which can induce these temperature changes. So when you put a lot of waste materials, you can change the condition of the water and heat it. For instance, um, by experimentation, I have found that water is always when water, for instance, you take a water at room temperature, which is about 35 degrees, and then you add a little bit of sodium hydrochloride, you boost the temperature to about 30 plus. So you increase the temperature. So just a little bit of chemical in the water can also change the nature of the water. And total phosphate. The total phosphate is the sum of the total reactive and condensed organic phosphorus. And phosphate is actually needed for all organic life forms, like plants and human beings. And if you are a biology student and you have heard about the Krebs cycle, it supports the Krebs cycle. Actually, Krebs cycle is simple. If you, what do you call it? uh, Somebody would take a lot of alcohol, you get a hangover. When you get a hangover, the Krebs cycle actually need water to complete it, so you get a hangover. Nitrate. These are inorganic compound made of nitrogen and oxygen. That is NO3, one part of nitrogen and three part of oxygen molecule. So that is the nitrate, okay? And too much of it in the water can be a lot of problem to the quality of water. Turbidity, which I explained the other time, but I will explain again, is the measure of the degree to which water loses its transparency due to the presence of some of all total solid and liquid particles. So that is in the liquid, you see it as crystal clear liquid, but there are solid that are suspended in this aqueous or liquid. They are particles that are hanging in. And if you pass a light through the liquid, then you can see through it, or you put a paper behind it, and you can read through, then the water is said to be less turbid, or is very clear. In simple terms, turbidity is the clarity of the water. So when you cannot see through the water and it's very opaque, then you say the water is very turbid, that you cannot see through. Total solid. This is the measure. It is the measure of all the suspended and dissolved solid in water. So that is the measure of suspended or dissolved solid that is what is termed total solid. So if you come across these terms, that is the meaning of it. And these are the determinant factors that determines that whether water is either clean or unclean. And there are various weights that are used to determine, so we will learn about, as we progress, we will learn about some of these determinant factors that are used in, for instance, we have the Canadian CCMWQI, that is the Canadian uh, water quality index. The Canadian have got a nice formula for defining this determinant to check whether the quality of water is good or is not good. Okay. WHO have guidelines. So as you see in some of the results from, they have guidelines for which water is classified as clean or unclean. So we have health guidelines. These are the two main guidelines, health guidelines, which take into account chemical and radiological constituents that have the potential to directly adversely affect human health. Okay, so in the guidelines, these are some of the things they look at. If the water is chemically clean and radiologically, it passes the test, then it's said that human being can, take it without no adverse effect. Acceptability guidelines, which include parameters that may not have any direct health effect but result in objectionable taste or odor in the water. So, for instance, when the water is more turbid, that is unclear, like the brim water, which you cannot see through. When a coin falls through it, you cannot see it down. Then we say it's objectionable. The look of it will not even, you will not get the attraction of tasting it because it's so turbid or it's so dirty. And then when it's the more turbid it is, the probability that it will smell is there. So we look, the acceptability guidelines include these parameters, which directly also affect health, but in objectionable taste or odor. So if the water smells, that means it's not good. And these are the guidelines, two main guidelines that the WHO accepts. Okay. So they are, like I said earlier, they are weighted, the weighted arithmetic method, W QI methods that are used in determining. So this is a simple formula. Don't be scared about the sigma sign. It's just a summation. The summation, okay, let me go gradually. The quality, the weighted arithmetic quality index method classify the water quality according to the degree of purity by using the most commonly measured quality variables. So as you know, WQI is water quality index. So if you see the QI is the quality index. And then for each parameter, it is calculated using this formula. The quality index is equal to 100, and then the estimated concentrated parameter of the analyzed water, that's the last analyzed, or for within a given range, the analyzed parameter of the water. And then VO is the ideal value of this parameter in pure water. uh, and it ranges from pH, which is acceptable, that is 7.0, like I have told you, that is the acceptable range of alkalinity. And then DO, which is the dissolved oxygen, uh, 14 milligram per liter. And then we have the XI, which is the recommended standard value of the height parameter. The unit weight for each water parameter quality is calculated using the following formula, which follows. The unit weight, which is WI for each water quality, is then calculated using the formula WI, and then divided by K over SI, okay, where K is a proportionality constant and can be calculated using the following method. That is K 1 over the sum total of SI parameter. Okay, so these are the method that is used in calculating some of the things that see on the sheet, the results sheet. Okay, and in treating this water, because I've been treating a lot of people on various degrees of injuries, you know, um, I didn't have enough of copper oxide. So what came to mind was to use the copper nitrate to be able to get nano material to be able to treat the water. So I use copper nitrate to create the nano material that was used in treating this brim water, and it gave us some interesting results. But Nash is not here to, I hope it is clear, and it can be be seen. Otherwise, I can open it
Can
and
you
draw it a
open
little
it
bit.
up, please? Is this for the
Okay.
sediment or is this for the water? Clear water.
For the water, for the water,
Is this what we
for
saw
the
last week?
yeah. This is what you saw last time, but it is for the brim water. And actually, Nash having completed this one also, because I gave him sediments to work on, and then also the E. coli, the biological and E. coli, results to work on.
When would we see the sediment?
The sediment is what I'm, it's very, Mr. Kesh, working here sometimes you need to pamper them, it's not easy, working in an environment like this, but
Can we see what is the change? Can you open it up further?
you said
Okay, yeah, okay. We don't
it's okay.
see the, yeah, okay, that's good.
It's okay like this. Okay, that's
Yeah, that's
the
the Nuclear
for
Chemistry and Environmental Research Center, okay.
okay. So this is the drinkable guidelines for the WHO standard, excuse me, and then Ghana Water and Sewage standard. So we are matching both parameters, and we are
I
comparing values.
think what you've done again as before, you have put mixed columns again. Because I said, it says total dissolved solid, river brim
Mm-hmm.
control 136, river brim treated 239. The columns have been back to fronted.
Okay. Uh,
I think you better
total
get this back to him and get this sorted
to,
because we
total solid. Total solid. That is the range. The WHO range is 1,000,
yeah. No, you see, the control is 136, and then when you treated it, it's gone up to 239. I don't think that's correct. Or is the conductivity that way? And
Is the
then you have
conductivity
That
range
was conductivity. Yeah,
conductivity.
good
Yeah.
the one below it, where you
because
can see
The
the
one
pool of
below it,
dissolved
yes.
solids.
Sorry, the one below it.
Yeah, 63.5 and 1161 has gone way up for the treated water. Is that correct?
yeah, this is the total TDSS. That's the total dissolved solid.
Yeah,
Right.
it's
Did
gone
it go
up.
way up on the treated? Shouldn't it be the other way around?
No, normally the range is 1,000,
No,
and
we're not
then
talking about the range. You see, the figure 63.5 is in the wrong place. It should be in the other column.
okay,
Or is it 11.61?
Mr. Kesh, this is the, what do you call it? The control. The control is the
Yeah. We
treated.
understand that. There is some discrepancies on that total dissolved solid.
Okay.
You
I
understand?
will
It's
have,
Is it about,
yeah,
11.6 or is it 63.5?
yeah. I will have them, look at it
Get it
again.
checked because this is very. It's the same with your calcium at the bottom, and it's the
Cal
same with magnesium.
yeah.
The figures have been put back to front. You got to change your what do you call secretary. She could be dyslexic because we
Okay.
see the same thing again and again, and institute at this level should not have this kind of mistakes.
Actually, Mr. Kesh, Nash does a very good work, but he and one guy here, they do a very good work, but the
No, it's
high
just entering the data, which is
entering the data, everybody is in a hurry here,
yeah.
and so
But
sometimes
when you get
some
them next time, look at it
mhm,
before you present it. Tell them they got to change it because it's
okay,
very easy to see.
okay.
We see this with CO, with copper oxide. Uh,
So is way like the turbidity is very high, you know. That is
Yeah, if
8.
you look at the
That,
apparent color, is a huge difference.
yeah,
Even with the true color, it's a huge difference.
yeah. So there's a huge what do you call it, difference. Only that the water is so polluted that if you treat it, you even see that, you know, it's, what do you call it, the sediment are the sediment that
Hello. Have we lost it?
Hello. Yes. Hello, Benjamin.
See if he comes back. Give him a few seconds. If not, when he comes back, we can, because this is the last page on his presentation. But we see the changes are huge. Notice the calcium and notice the total magnesium. They've written in the wrong way.